class 9 this is advanced mathematics the question was asked, that is, this is the question is that PA is the power set. PA is the power set of A. Now you have to show that first PA intersection B is equal to PA intersection PB. PB is always true, and here your second is that P A union B is equal to PA union PB may not be always true. So first of all, let me do this proof first of all. After that I will do that proof. Let A set belongs to x1 x2 and your B set it belongs to x1 x2 x3. Now here your A union B will be x1 x2 and x3. Now here your PA, this will be power set A, this will be x1 x2 and x1 x1 x2 and your phi, and your B's power set B will be this will be x1 x2 x3, then x1 x2 x1 x3 x2 x3 and x1 x2 x3 and your phi 1 2 3 4 5 6 7 8. This, so here you see that PA union PB, this set will be see x1 x2 x3 x1 x2 x1 x3 x2 x3, then x1 x2 x3 and then phi. This will be PA union B, and here your PA union B, this will be same x1 x2 x2 x3 and x1 x2 x1 comma x2 x1 x2 and then x1 x3 and x2 x3, and this is x1 x2 x3 and then phi. So from here we see that PA union B is equal to PA union PB. Now if we take these two disjoint set, now let us take, here you see these are equal, Now if we take two disjoint sets, let me take two disjoint sets. If we take two disjoint sets, that is A intersection B is your phi. If we take two disjoint sets, that is A equal to x1 x2 and your B is equal to x3, two disjoint sets. So here your A union B will be x1 x2 and x3. So here PA will be x1 x2 x1 x2 and your phi, whereas PB, this will be x3 and your phi. So now when I PA union PB, what I get, that is x1 x2 and x1 x2 and x3 and your phi. But here P A union B, here I get, that is x1 x2 x3 x1 x2 x1 x3 x2 x3 x1 x2 x1 x3 x2 x3, then x1 x2 x3 and your phi. 2 3s are 8, 2 to the power 2 to the power of 3 is 8, 1 2 3 4 5 6 7. So here you see that P, here A union B, here we find that, here we find that our P A union B is not equal to PA union PB. So here from this we conclude that it may not be always true. If this is disjoint set, then it is not true. Now let me prove the first one. Here you do one thing, that is first one, again let A is equal to x1 x2 and your B is equal to x1 x2 x3. So here your A intersection B will be x1 x2. Now here PA, this will be again, here you see x1 x2 and x1 x2 and your phi, and your PB, this will be 2 2 the 4, this will be again your x1 x2 x3 x1 x2 x1 x3 x2 x3 and one x1 x2 x1 x3 and x2 x3, and then x1 x2 x3 and then 5. We close the set 1 2 3 4 5 6 7 8. It's correct. So now if we take PA intersection PB, then your common elements are x1 x2 x1 x2 and phi. This is the common elements. Now if we take this here PA intersection B, so your set will be x1 x2, again x1 x2 and your phi. So from here we see that A intersection B is equal to PA intersection PB. Now let us take two disjoint set. Now let us take two disjoint set. If we take two disjoint sets, that is disjoint set, two disjoint set, that is A is equal to x1 x2 and your B is equal to x3, that is A intersection B, A intersection B is equal to 5. So here we see that A intersection B is equal to 5. Now PA, this is here you see x1 x2, then x1 x2 and your 5, and here you see PB, this will be x3 and 5. Now here PA intersection PB, here you see common is 5, this is your common. Now if you take PA intersection B, then A intersection B, that is as we have to find subset of 5. Subset of 5 is 5, and their because it is power set, so subset of 5 is 5 and their set, so this is this. So here we see again PA intersection B is equal to PA intersection PB. So in both the cases we find it is true, so this is always true. So here there is no confusion must arise here, because A intersection B 5. So subset of 5 is 5. Subset of 5 is 5. But since it is a power set, so the set of that set of the subset. So these two are equal. So this is proved. And if you have any doubt or if you find anything problem, you can write in the comment section. This is over.